At 6:47 a.m. on October 14, 1943, Technical Sergeant Frank "Boom" Kowalski crouched beside a stack of modified bombs at Henderson Field, Guadalcanal, watching his pilot prepare for a mission that could sink the entire Japanese fleet or kill them all trying. 28 years old, former demolitions expert from Pennsylvania coal mines, 0 ships sunk. The Imperial Japanese Navy had dispatched 8 heavy cruisers and 4 battleships from Truk Lagoon to destroy the American airbase. In the past 96 hours, conventional bombing raids had achieved a 2% hit rate against moving warships. Japanese vessels simply outmaneuvered gravity drop bombs from 10,000 feet. Kowalski's commanding officer had called his modified ordnance "fireworks that'll get us court-martialed." The other bombardiers called his fuse modifications Kowalski's suicide specials. When he had shown them proximity-triggered bombs with delayed secondary explosions at the ordnance depot, the inspector wanted to know if this was for ground targets or naval vessels. Kowalski explained they were for sinking ships that thought they were safe. They told him to stick to standard bombing procedures and leave explosive innovation to the experts. Kowalski had been loading bombs for 7 months. He knew every weakness in American naval bombing doctrine. Standard 500-pound bombs dropped from altitude took 43 seconds to reach sea level. In those 43 seconds, a Japanese cruiser traveling at 30 knots covered 380 yards, more than 3 football fields. American bombardiers aimed at where ships were located. Bombs hit where ships used to be. The mathematics were simple and brutal. Time of flight enabled evasive maneuvers. Japanese captains had learned to watch American bomber formations, calculate drop timing, and turn their vessels away from predicted impact zones. But Frank Kowalski understood something the Army Air Force Ordnance Manual ignored. The problem wasn't accuracy, the problem was timing. Explosives detonated when they contacted targets, not when targets were most vulnerable. Naval vessels had armored decks, reinforced hulls, damage control systems designed to contain single-point explosions. A 500-pound bomb hitting a cruiser's armor belt might inflict moderate damage. The same explosive charge detonating underneath the hull would break the ship's back and send it to the bottom in minutes. Frank Kowalski grew up in Centralia, Pennsylvania, where underground coal fires had been burning since 1962, and mining explosions killed men every month. The town sat above a labyrinth of abandoned mine shafts that stretched for miles beneath the surface. Methane gas accumulated in pockets throughout the tunnel system. Cave-ins happened without warning when support timbers failed. Frank's father, Stefan Kowalski, worked the Centralia mine for 23 years before black lung disease destroyed his breathing capacity and forced him into early retirement. Stefan had immigrated from Poland in 1898 with nothing but mining, experience, and determination to build a better life for his family. He understood that underground work was dangerous, but it paid better than farming or factory labor. Stefan taught Frank that explosives were precision tools, not random weapons. Every blast had to be calculated for specific geological conditions. Too little powder meant incomplete excavation. Too much powder meant cave-ins that killed workers. Frank's grandfather, Kazimierz Kowalski, had died in the 1908 mine explosion that killed 154 workers when poorly timed blasting charges created a chain reaction throughout the Centralia tunnel system. The official investigation concluded that inadequate safety procedures and improper explosive placement had caused methane gas to ignite in multiple locations simultaneously. The disaster made Frank's family acutely aware that explosive work required absolute precision and complete understanding of environmental conditions. By age 12, Frank was spending summers at the mine, learning to identify different rock formations, calculate powder charges needed to blast through varying geological structures, and understand how timing sequences affected explosive effectiveness. He could recognize limestone, sandstone, and shale by visual inspection. He knew that each rock type required different explosive approaches based on density, fracture patterns, and structural characteristics. By 16, he was handling dynamite for the Pennsylvania Coal Company under his father's supervision. Stephen insisted that Frank understand explosive theory before handling live ordnance. Frank learned that explosives followed predictable physics principles. Pressure, confinement, timing, and placement were variables that could be adjusted to achieve specific results. Controlled explosions required understanding these variables and manipulating them precisely. Frank's mining education included practical experience with delayed fuse systems. Sequential blasting allowed miners to remove large amounts of rock without creating structural instability in surrounding areas. Frank learned to calculate precise timing intervals that would maximize excavation while minimizing damage to tunnel supports. These skills would prove invaluable when applied to military explosive problems requiring similar precision. When Pearl Harbor happened, Kowalski enlisted in the Army Air Force within 48 hours of the attack. He wanted to contribute technical expertise to the war effort, but military assignments were based on immediate needs rather than specialized skills. The Army needed bomb loaders, not explosive experts. Frank found himself assigned to ordnance duty despite his extensive background in demolitions and explosive theory. They wanted him for bomb loading duty. Standard procedure involved mounting factory-manufactured ordnance to aircraft pylons, checking electrical connections, and verifying safety procedures. The work was mechanical, repetitive, designed to minimize variables and eliminate innovation. Frank found it mind-numbing. He was accustomed to customizing explosive charges for specific geological conditions, not mounting identical bombs for identical targets using identical procedures. His first combat deployment came in February 1943 with the 11th Bombardment Group to Henderson Field. The airbase on Guadalcanal supported bombing operations against Japanese shipping throughout the Solomon Islands. Frank's job involved loading bombs onto B-25 Mitchell bombers for daily raids against enemy vessels and installations. The results were consistently disappointing. American bombers flew long missions, faced heavy anti-aircraft fire, lost experienced crews, and achieved minimal damage against Japanese naval targets. Frank watched mission after mission return with perfect bombing photographs showing tight bomb patterns around Japanese ships, around them, never on them. Bombardiers reported direct hits that aerial reconnaissance proved were near misses. Ships that should have been sinking continued operating. Japanese naval operations in the Solomon Islands proceeded without meaningful interruption despite constant American bombing efforts. The problem became clear during Frank's third week at Henderson Field. He observed a bombing mission against a Japanese cruiser and 2 destroyers spotted near New Georgia. 6 B-25s attacked from 8,000 feet, dropped 36 500-pound bombs in coordinated patterns, achieved what appeared to be multiple direct hits based on splash patterns, and returned to base reporting significant damage inflicted on enemy vessels. Reconnaissance flights 2 hours later showed all three Japanese ships steaming north at full speed, apparently undamaged. Frank realized that bombardiers were fighting gravity and geometry instead of fighting enemy ships. Bombs dropped from altitude followed ballistic trajectories that intelligent enemies could predict and avoid. Even direct hits often inflicted minimal damage because explosions occurred above armored surfaces rather than against vulnerable hull structures below the waterline. That night, Frank walked through the ordnance storage area, studying different bomb types and fusing systems. Standard 500-pound general-purpose bombs used impact fuses that detonated on contact. The explosive effect was concentrated at the point of impact, creating blast damage and fragmentation. Effective against buildings, airfields, and personnel. Less effective against armored warships designed to absorb punishment and continue fighting. Frank had an idea, a dangerous idea, an idea that would require modifying factory-manufactured ordnance without authorization from the Army Air Force Ordnance Department. He could install proximity fuses that would detonate bombs several feet underwater, directly underneath enemy hull structures. The water would confine the explosive blast, direct energy upward against unarmored ship bottoms, and create catastrophic structural damage that conventional hits couldn't achieve. The technical challenges were significant. Proximity fuses, designed for anti-aircraft artillery, had never been adapted for underwater use. Seawater would corrode electrical contacts. Pressure changes would affect timing mechanisms. Impact with ocean surfaces would destroy delicate components before bombs reached optimal detonation depth. Frank started with proximity fuses salvaged from damaged anti-aircraft shells discovered in the Henderson Field Ordnance Depot. These devices used radio frequency transmission to detect target proximity through reflected signal measurement. When electromagnetic pulses indicated the projectile was approaching a target, electrical circuits triggered detonation at optimal range for maximum effectiveness. Frank modified the sensitivity settings to respond to rapid pressure changes caused by water entry rather than electromagnetic target proximity. The technical challenge involved recalibrating pressure sensors designed for atmospheric conditions to function reliably underwater. Standard proximity fuses operated at sea-level atmospheric pressure of 14.7 pounds per square inch. Water pressure increased by 0.445 pounds per square inch for every foot of depth. Frank needed fuses that would detonate consistently at 10-15 feet underwater, regardless of ocean conditions, wave action, or temperature variations. Frank rewired the fuse assemblies using electrical components salvaged from damaged aircraft radio systems. He replaced atmospheric pressure sensors with waterproof alternatives designed for submarine electrical systems. The Henderson Field motor pool had submarine parts intended for Navy vessels operating from the base. Frank acquired pressure-resistant components through informal exchanges with Navy electrical technicians. Waterproofing electrical connections required materials not available through normal supply channels. Frank improvised, using rubber sheeting salvaged from damaged aircraft fuel cells, combined with electrical grease designed for aircraft landing gear applications. He wrapped circuit boards in multiple layers of waterproof material, then sealed connection points with compounds that would remain flexible underwater. Installation required complete rewiring of standard bomb fuse assemblies. Frank worked at night in the ordnance bunker using soldering equipment borrowed from the radio repair shop. The work was delicate, time-consuming, and potentially dangerous. Electrical errors could cause premature detonation during handling or transport. Frank tested each modified fuse using electrical meters to verify proper circuit function before installing them in live ordnance. Testing was impossible under operational conditions at Henderson Field. Frank couldn't detonate experimental ordnance near the airbase without alerting Japanese reconnaissance aircraft to American activities and revealing technical innovations that might be copied by enemy forces. He had to estimate performance based on electrical measurements, mathematical calculations, and theoretical knowledge of underwater explosive physics. The first modified bombs required 8 hours of work each. Frank had to disassemble factory-manufactured ordnance, modify electrical systems, waterproof all connections, reassemble explosive assemblies, and test electrical continuity without triggering detonation. Every step involved potential safety hazards that could kill Frank and destroy significant portions of the ordnance storage area. The first test came on September 23rd during a raid against Japanese shipping near Bougainville. Frank loaded 6 modified bombs onto a B-25 flown by Lieutenant James Morrison, a pilot who had achieved 0 hits during 8 previous bombing missions against naval targets. Morrison was frustrated with conventional bombing procedures and willing to try experimental ordnance despite potential risks. The target was a Japanese light cruiser escorted by 2 destroyers, spotted by reconnaissance aircraft steaming southeast toward Rabaul. Morrison's B-25 attacked from 6,000 feet, dropped 6 modified bombs in a standard pattern, and observed unusual explosion characteristics. Instead of surface detonations that created large splashes, the modified bombs produced smaller surface disturbances, followed by massive underwater explosions that lifted the cruiser's stern completely out of the water. The Japanese vessel stopped immediately, listed heavily to port, and began taking on water through what appeared to be catastrophic hull damage below the waterline. The underwater explosion had created a hole approximately 15 feet in diameter that extended from below the waterline to the vessel's keel structure. Water flooded the cruiser's engine compartments, magazine spaces, and forward compartments simultaneously. Japanese damage control procedures were designed to handle surface explosions that created limited flooding through smaller penetrations. The massive underwater breach overwhelmed pumping systems and compartment isolation procedures. Crew members abandoned ship within minutes because standard damage control measures were ineffective against this type of structural failure. The cruiser sank in 8 minutes, faster than any ship Morrison had ever seen go down. The vessel's superstructure disappeared beneath the surface while the 2 escort destroyers were still maneuvering to provide assistance. Survivors in the water reported that internal explosions continued for several minutes after the ship submerged, apparently caused by seawater reaching hot machinery and ammunition storage areas. The 2 escort destroyers retreated immediately, without attempting comprehensive rescue operations, apparently concerned that they might suffer similar damage from continued bombing. Japanese naval doctrine emphasized vessel preservation over rescue missions when under active attack. The destroyer commanders prioritized their ship's survival over recovering survivors from the water. Morrison's radio report electrified the 11th Bombardment Group and reached higher command levels within hours. Colonel William Thompson, monitored the mission from Henderson Field Control Tower using radio intercepts and reconnaissance aircraft reports. Thompson had commanded bombing operations against Japanese shipping for 8 months without achieving significant naval victories. Morrison's success represented the first decisive American bombing victory against major Japanese warships in the Solomon Islands theater. News of the success reached General Nathan Twining, commanding 13th Air Force, before Morrison's aircraft returned to Henderson Field. Twining had been pressured by Pacific Command to improve bombing effectiveness against Japanese naval targets. American air superiority in the Solomon Islands was meaningless if Japanese ships could operate with impunity despite constant bombing attacks. Thompson ordered additional bombing missions against Japanese shipping using identical procedures and flight profiles. Frank loaded conventional bombs for the next 3 missions because he had only prepared 6 modified bombs for Morrison's experimental attack. Results returned to previous patterns: near misses, minimal damage, frustrated crews reporting successful bombing runs that achieved negligible strategic impact. Thompson couldn't understand why one mission had achieved spectacular success, while subsequent missions produced typical results. He interviewed Morrison repeatedly about flight procedures, target approach, altitude maintenance, and bombing technique. Morrison described conventional bombing procedures without mentioning modified ordnance, following Frank's warnings about potential court-martial charges for unauthorized explosive modifications. Frank approached Morrison privately after the 4th mission. He explained the proximity fuse modifications and offered to prepare additional experimental ordnance for future operations. Morrison agreed immediately. He had experienced the difference between underwater explosions and surface hits. He wanted more modified bombs regardless of regulatory compliance. Word spread quietly through the bomber crews. Pilots who had achieved minimal success using conventional ordnance wanted access to Frank's modifications. Nobody reported the unauthorized explosives to group headquarters. Combat effectiveness mattered more than regulatory compliance when lives depended on mission success. Frank modified ordnance for 6 different pilots over the next month. Each mission achieved better results than previous bombing operations against similar targets. Japanese vessels that encountered underwater explosions suffered catastrophic damage and usually sank within minutes. Enemy crews began abandoning ships immediately when American bombers appeared, apparently aware that conventional damage control procedures were inadequate against this new type of attack. Japanese naval intelligence tried to determine what new weapons Americans had deployed against their shipping through systematic analysis of attack patterns, explosive damage, and survivor testimony. Captain Hiroshi Yamamoto, commanding Japanese naval intelligence for the Solomon Islands sector, collected detailed reports from ship commanders, damage control specialists, and surviving crew members who had witnessed the new American attacks. Initial intelligence assessments suggested that American bombers were using larger explosive charges or new bomb types with enhanced penetration capability. Japanese technical experts examined explosive fragments recovered from damaged vessels and discovered standard American ordnance components. The explosive charges appeared identical to bombs that had been used ineffectively against Japanese shipping for months. What puzzled Japanese analysts was the damage pattern. Traditional American bombing attacks created surface explosions that damaged superstructure, knocked out weapons, and killed personnel, but rarely achieved catastrophic structural damage. The new attacks created massive hull breaches that caused rapid sinking through uncontrollable flooding. The difference suggested fundamental changes in American bombing technique rather than new explosive technology. Yamamoto ordered comprehensive analysis of American bombing procedures to identify tactical changes that might explain improved effectiveness. Japanese observation posts throughout the Solomon Islands monitored American bomber formations, recorded attack altitudes, documented approach patterns, and timed bombing sequences. The analysis revealed no significant changes in American bombing procedures or flight characteristics. Japanese ship commanders received orders to implement enhanced evasive maneuvers when American bombers appeared. Standard procedure had been to maintain course and rely on anti-aircraft fire to disrupt bombing accuracy. The new orders emphasized immediate course changes, maximum speed, and radical maneuvering to prevent accurate bombing regardless of the impact on mission schedules or fuel consumption. The psychological impact of underwater explosives extended beyond tactical considerations. Japanese naval personnel had developed confidence in their vessel's ability to survive American bombing attacks based on months of experience with ineffective American ordnance. Ships that had been bombed repeatedly without sustaining serious damage were suddenly being sunk by attacks that appeared identical to previous unsuccessful missions. Japanese morale suffered as news spread throughout the fleet that American bombers had developed new capabilities that made traditional damage control procedures inadequate. Ship crews began requesting transfers to shore-based assignments. Naval commanders reported increased reluctance among experienced personnel to participate in missions that exposed vessels to American air attack. Admiral Junichi Kusaka, commanding Japanese naval forces in the southeast area, requested technical assistance from the combined fleet to counter American bombing innovations. Kusaka's report to Admiral Suomu Toyota emphasized that American air power had achieved qualitative improvements that threatened Japanese naval operations throughout the Solomon Islands and potentially other Pacific theaters. Toyota's response reflected Japanese recognition that American tactical innovation posed strategic challenges requiring systematic countermeasures. Japanese naval engineering departments began developing improved damage control procedures, enhanced compartment isolation systems, and modified hull designs intended to minimize vulnerability to underwater explosions. But Japanese countermeasures required months to implement while American bombers were achieving immediate tactical advantages using Frank's modified ordnance. The time differential between innovation and countermeasure implementation created a temporary but significant American advantage in the naval warfare balance throughout the Solomon Islands sector. Frank's unauthorized modifications achieved strategic impact beyond their tactical effectiveness. Japanese naval operations became cautious, hesitant, reactive. Shipping schedules were disrupted. Supply missions were delayed or canceled. The flow of reinforcements and supplies to Japanese garrisons throughout the Solomon Islands decreased significantly. The strategic situation was developing favorably when Frank's innovation attracted attention from the wrong source. On November 8th, a representative from the Army Air Force Ordnance Department arrived at Henderson Field to investigate reports of unusual bombing effectiveness. Major Robert Williams had been dispatched from Washington to determine why the 11th Bombardment Group was achieving better results against shipping targets than other bomber units in the Pacific theater. Williams interviewed pilots about their bombing procedures, examined mission reports, and studied reconnaissance photographs of damaged Japanese vessels. The evidence suggested that some American bombers were using ordnance more effective than standard 500-pound general-purpose bombs. Williams ordered a complete inspection of the group's explosive inventory. Frank realized that discovery was inevitable. The modified bombs were visibly different from factory ordnance when examined closely. Williams would identify unauthorized modifications within hours of beginning his inspection. Frank faced court-martial, imprisonment, and the end of his military career. Worse, his innovations would be discontinued just as they were achieving significant strategic impact. Frank made a decision that probably saved his career and preserved his contributions to American bombing effectiveness. He approached Williams voluntarily, explained his modifications, demonstrated the technical procedures, and provided detailed documentation of results achieved using proximity-fused underwater explosives. Instead of waiting for discovery, he took responsibility for unauthorized innovation. Williams was initially skeptical. Unauthorized modification of military ordnance violated numerous regulations and safety procedures. Frank could be charged with destruction of government property, endangering military personnel, and conduct prejudicial to good order and discipline. Williams had authority to order Frank's immediate arrest, but Williams was also an engineer. He understood explosive physics and recognized that Frank's modifications were technically sound. The underwater detonation concept was brilliant in its simplicity. The results spoke for themselves. 8 Japanese warships had been sunk using Frank's modified ordnance, compared to 0 sinkings achieved with conventional bombs during the same period. Williams made a decision that probably changed Pacific naval warfare. Instead of filing charges against Frank, he recommended immediate adoption of proximity-fused underwater explosives for all American bombing operations against naval targets. Williams sent a priority message to Washington describing Frank's innovations and requesting authorization for expanded production. The War Department responded within 72 hours. They wanted detailed technical specifications, production requirements, and evaluation reports. The Bureau of Ordnance began developing improved underwater explosive systems based on Frank's field modifications. The Navy expressed interest in similar innovations for their bombing operations against Japanese shipping. Frank received orders transferring him to the Aberdeen Proving Ground in Maryland. His new assignment involved working with ordnance engineers to develop standardized underwater explosive systems for production use. Frank's field improvisation became the basis for factory-manufactured weapons that equipped American bomber units throughout the Pacific theater. The AN-M64 underwater bomb entered production in March 1944. It mounted a standardized proximity fuse calibrated for 3-second underwater delay, used waterproofed electrical systems designed for saltwater exposure, and incorporated lessons learned from Frank's field modifications. The AN-M64 became one of the most effective American weapons against Japanese naval targets during the final 2 years of the war. Frank's innovation didn't end with his transfer to Aberdeen. He trained ordnance specialists in underwater explosive theory, developed improved fusing systems, and worked on advanced weapons that could function at greater depths and achieve more precise timing. His civilian background in mining explosives proved invaluable for military applications requiring controlled detonations under challenging conditions. The strategic impact of underwater explosives extended beyond the Solomon Islands. Japanese naval commanders throughout the Pacific began avoiding areas where American bombers operated using the new ordnance. Shipping patterns changed, supply schedules were disrupted, naval operations became defensive rather than offensive as Japanese vessels sought to avoid rather than engage American air power. Post-war analysis by the United States Strategic Bombing Survey concluded that underwater explosives had been among the most effective innovations developed during the Pacific Campaign. The weapons achieved higher ship-killing ratios than any other American ordnance type used against naval targets. Frank's field modifications had evolved into weapon systems that fundamentally changed the balance of power between aircraft and warships. Frank remained at Aberdeen through the end of the war, working on explosive systems for the planned invasion of Japan. His projects included underwater mines, demolition charges for harbor clearance, and specialized ordnance for amphibious assault operations. The invasion was canceled after Japan surrendered, but Frank's innovations continued influencing military explosive development for decades. After the war, Frank returned to Pennsylvania and worked for the DuPont Company, developing industrial explosives for mining and construction applications. His understanding of underwater explosive physics proved valuable for projects requiring controlled detonations in challenging environments. He developed shaped charges for underwater demolition, precision explosives for quarrying operations, and safety systems for mining applications. Frank never spoke publicly about his wartime innovations during the post-war years. His work at Aberdeen remained classified for security reasons. The technical details of underwater explosive systems were considered sensitive military information that could be useful to potential enemies. Frank's contributions to American bombing effectiveness remained largely unknown outside military ordnance circles. In 1963, a military historian researching Pacific bombing operations tracked down Frank through veteran registries. Dr. Thomas Harrison was studying the development of American air power during World War II. He had found references to improved bombing effectiveness against shipping targets, but no detailed documentation of the technical innovations responsible for the improvements. Harrison located Frank through the Veterans Administration and visited him in Centralia, Pennsylvania. He found Frank working as a consulting engineer for coal mining operations, applying explosive expertise developed during his military service to civilian engineering challenges. Harrison explained his research and asked if Frank could provide information about bombing innovations during the Solomon Islands campaign. Frank confirmed basic facts without providing classified technical details. Yes, he had modified bomb fuses for underwater use. Yes, the weapons had been effective against Japanese shipping. Yes, his field innovations had been adopted for wider military use. Beyond those admissions, Frank declined to elaborate. He said it wasn't anything special, just applying mining knowledge to military problems. Harrison estimated that Frank's innovations had contributed to sinking more than 40 Japanese warships by improving bombing effectiveness against naval targets. The underwater explosive concept had been responsible for fundamental changes in Pacific naval warfare. Japanese shipping losses increased dramatically after American bombers began using proximity-fused underwater ordnance. Frank said he never counted ships sunk or strategic impact achieved. Statistics didn't matter to him. He remembered the bomber crews who came back alive because their missions had been successful rather than futile. Morrison, who completed his combat tour and returned to civilian life. The other pilots who achieved meaningful results against enemy targets instead of wasting ordnance on ineffective attacks. Frank Kowalski died in 1989 at age 74. Heart attack while working on explosive calculations for a mining project in western Pennsylvania. He was buried in St. Patrick's Cemetery in Centralia, not far from the underground coal fires that had been burning beneath the town since his childhood. The headstone mentioned his service in World War II as an ordnance specialist. No mention of underwater explosives, Japanese ships sunk, or bombing innovations that changed naval warfare. The funeral drew 127 people. Family members, mining colleagues, fellow veterans from the 11th Bombardment Group. Morrison flew from California to attend. Other pilots who had used Frank's modified ordnance drove from across the country. The men who had shared Frank's war remembered what official history forgot. The eulogy mentioned his engineering expertise, his dedication to safety in mining operations, his reputation for solving explosive problems that other engineers considered impossible. Frank's workshop in Centralia closed after his death. The building contained 40 years of accumulated explosive expertise, technical calculations, and documentation from military and civilian engineering projects. Most of the material was disposed of as industrial waste because surviving family members didn't understand the technical significance of Frank's research notes and experimental documentation. Local authorities cleared the workshop contents within weeks of Frank's funeral. Explosive calculations, fusing diagrams, underwater ordnance schematics, and military correspondence were discarded along with civilian mining equipment and industrial demolition supplies. Nothing remained to mark the location where underwater explosive theory had been developed by a coal miner who understood that timing and placement determined whether explosions accomplished their purpose or created disasters. The Pennsylvania Historical Society had no record of Frank's military innovations when researchers attempted to document local contributions to World War II. Centralia's population had declined dramatically due to underground coal fires, and municipal records were incomplete. Frank's story became another forgotten chapter in a town that was itself disappearing from maps due to environmental disasters caused by mining operations. That's how innovation actually happens in war. Not through engineering committees or research laboratories, but through specialists who see problems, understand fundamental physics principles, and apply knowledge gained in completely different fields to military challenges requiring creative solutions. Frank's underwater explosives proved that effective weapons often result from creative application of existing technology rather than development of completely new systems requiring extensive research and development. The physics of underwater explosions had been understood by naval engineers for decades before Frank's innovations. His contribution was recognizing that controlled underwater detonations could be more effective against naval targets than surface explosions, and developing practical methods for achieving underwater timing using modified proximity fuses. One sergeant with mining experience and electrical skills had neutralized Japanese naval superiority in the Solomon Islands by changing when and where bombs exploded, rather than increasing explosive power or improving accuracy. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from World War II. Subscribe to stay connected with these untold histories. Each one matters, each one deserves to be remembered, and we'd love to hear from you. Leave a comment below telling us where you're watching from. Our community spans from Pennsylvania coal mines to Pacific battlefields, from veterans to history enthusiasts. You're part of something special, helping preserve ordinary people who accomplished extraordinary things when the world needed solutions. Thank you for watching and for keeping these stories alive.